So, last problem. So I promised we were going to do something with other numbers other than just one in there. So we're going to do 1 to 2s. And then with your problem set that I have you guys work on, there'll be lots of other numbers in there. I want you to work on them to prove that you can do it. I will suggest to you that when you get balanced equations of things other than 1 to 3 and 1 to 2 and 1 to 4, that you might want to do the ugly math version, but we'll solve them, we'll set them up, and then you'll see my answer keys, and we'll cut another video and hopefully have a Zoom meeting. So this one, methane and oxygen. So 1 part methane reacting with 2 parts of oxygen gas. And it gives you carbon dioxide and water. We've done lots of these versions of balanced equations. So, and I wanted to start off with 4 grams of oxygen. So 4 grams, and then the molecular mass of oxygen is 32 because you've got 2 O's, not 1. 1 oxygen would be 16, but it's bonded together, so it's 2. So remember, for your molecular masses, 1 carbon, 4 hydrogens, that gives you the 16. 1 carbon, 2 oxygens, 44, and then water. Law of conservation of mass states that in a balanced equation, all of your masses should work up even. So if you would just add across the top, you'd say 16 plus 2 is 48. 44 plus 18 is 62. That doesn't come out even. But if you multiply that 2, that's 64 plus 16, that's 80. 44 plus 36, that's 80. Once you add up all the pieces on the balanced equation, your mass does come out even. So good way to check yourself. So let's set up your table. So you've got 0.125 moles of oxygen. So in a balanced equation, you've got twice as many pieces of oxygen as you do methane. So that means you need to cut your methane in half, 0.0625. Key. So 0.0625 moles of methane, 0.125 moles of oxygen. When you've started, you don't have any products yet. So when you change, you lose all of your methane, you lose all of your oxygen. Oh, but when you make your products, carbon dioxide had a 1, methane had a 1, so they're going to flip-flop. The water had a 2, the oxygen had a 2. Those are going to flip-flop. So plus 0.0625, 0.0125. So at the end, no reactants, there's your products. What do you need to do to balance things out? Just like what we were doing before. So carbon dioxide, you take your moles, multiply by your molecular mass. You're going to come up with about 2.75 grams of carbon dioxide when you're done. Water, 0.125 moles times 18 grams. So you actually wind up with fewer grams, even though you've got more pieces. It's just such a light molecule. Methane, 0.0625 times 16. Oh, you needed 1 gram of it to start. Okay. So here's all of your math. The trickiest part where most people mess up is understanding what to do with the 1 to 2 at the beginning and what to do with the 1 to 2 in the change line. It's tricky for a lot of people at the beginning. You have to understand that this means you need twice as much oxygen, and you're going to get then half as much carbon dioxide as you did oxygen and the same amount of water. You've got to understand what those mean. And now you can start to see when you get balanced equations with numbers all over the place, especially if you don't have a 1 somewhere in there to kind of keep things normal for you, where it gets a little bit more tricky. Okay, let me show the ugly math version now. Okay, so again, your numbers all come out the same. It's just a question of when do you want to do your math. So your first steps for all of your problems are the same. You're taking your grams of oxygen and you're converting it into moles. So that's the same here. The second step is key because this is where you're saying, okay, my pieces are turning into pieces or reacting with pieces. So here I'm in moles of oxygen. 1 mole of 2 moles of oxygen are only going to give me 1 mole of carbon dioxide. So you're winding up with fewer pieces. Well, let me multiply by the molecular mass. You're going to get your answer in grams. On your second one, so you're here in moles. Oh, well, it's actually a 1-to-1 conversion. So when you do your math, you can actually cancel out there if you want to. If you just want to say, I'm going to do 4 times 2 times 18 divided by 32 times 2, that's fine. But this is even 2 to 2 is really 1-to-1. That fraction balances for you. Oh, well, 2 moles of oxygen turn into 2 moles of water. Now I just multiply by 18 to get into grams. That's easy. The last problem, when you're trying to figure out how much methane you need in order to make the reaction go in the first place, I've converted it into moles. 4 divided by 32, that's what 1, taking your 4 and multiplying by 1 over 32 is. It's the same thing. Oh, here's our same 1 divided by 2 step coming in. And you're saying, wait a minute, I've got 2 moles of oxygen, but I only need 1 particle of methane to react with it. I need less methane relatively to start with in order to make the reaction go. I need twice as much oxygen as a reactant in order to make the reaction go. Oh, I need double the moles. Oh, this is my last step, converting it from moles of methane into grams, and it runs. So, as you're doing these, have your problem set up. You need to be very slow, take your time, be very intentional about your step. Notice that I write my labels out. A lot of people just want to put your numbers up. It's like, oh, it's 1 to 2, it's 44 to 1. And when you don't write your label, especially when you're just starting, you tend to make a mistake. And it's easy because you get going so fast, you forget where you are. And by writing, hey, it's grams per mole of where you are, you can actually catch mistakes before you make them. So, do the best you can. I'm going to send some emails out so we can schedule a Zoom meeting. And that way I can take some questions. And I will post answer keys after people have gotten a shot to do these. Do as much as you possibly can. If you need more help as far as examples of how to do these other than my answer keys, I really love Bozeman Science. Khan Academy is great, but sometimes it's a little bit on the dry side. Bozeman Science is great, but sometimes it's a little bit on the rapid side, so just be forewarned. Please email me. I will respond. You email me at 9 o'clock at night, I may let it go. You email me at 2 o'clock in the afternoon, I'm going to pounce on it. So I'll send it, we'll schedule a Zoom meeting, we'll get things going. Hopefully all of this will help you, and we'll take it from there. Good luck, happy problem solving. Jalapeno says adios, and we'll catch you next time. Bye.